YouTube live to broadcast. During the presentation, if you have any question, please type in the chat room. We will reply after the presentation. Because new coronavirus impact, we adjust today's topics a little bit. To introduce of the LoRa devices LC and LM, how to install and configure LoRa devices. The hands-on session is shifted to the next webinar. First of all, I would like to share with you what is LPWAN, Low Power Wide Range Network. It's the term about the communication technology for the longer distance transmit, with the lower the power consumption. By data rate and the coverage range, we separate different wireless communication into the three groups. They are the short range, long range, and the cellular. In the short range group, there are the Bluetooth, Zigbee, NFC, and else. Usually, the coverage is around 1 to 3 meters. The data rate is under the 255 kbps per second. Generally, they are used in the home or the building automation. In the cellular group, the coverage is related to the location of the base stations, like 4G. More base station, you will have the better signal coverage. Their speed rate can be up to even the giga level, like LTE Cat 18. So Wi-Fi, 2G, 3G, LTE, and 5G are in this group. Power distribution and remote data collection are suitable to use them. Now we move to the longer range one. As here you can see, the LPWAN is located in the list. It can reach to the longer the distance, usually 2 to 5 kilometers, even the longer, with the lower the data rate and the lower the power consumption. By these features, it can feed wild and distributed data access, like the environment monitoring and the power metering. User can based on list different features to choose which the most suitable the communication is. Regarding the global market size in the number of the connected LPWAN devices from the market respect. If the more devices can connect to the LPWAN network, it means more revenue behind. Now we are in the right time to join the list chain. Here you can see, with the 109% growth rate per year, it is going from the 14 million in the 2017 to the 1,151 million in the 2023. It's such huge market size. We believe that it will become a leading communication even more and more popular as time goes on. Nowadays, more and more the applications are driven with the popular IIoT, like water and gas metering, sensor monitoring, and the water level and the food management. The communication with the longer distance and the low power are suitable for this kind of the wide range application, such as the NB-IoT, LoRa, and LoRaWAN. With the LoRaWAN technology, users can access the environmental data remotely. WoMaster provided LPWAN connectivity with the different models, such as WR222. It can support the license band for the NB-IoT with the SIM card. However, some customers don't prefer the SIM card communication from the operators. Then you can consider the non-licensed band LoRa and the LoRaWAN. For LoRa, we have the two models for the LoRa communication. One is the Modbus RTU LoRa agent, LM100. You can treat it as the master to collect all of the data in the LoRa subnet. Another one is the LoRa end node LC144. It's a LoRa end node to connect to the end devices such as the sensor, RTU, remote transmitter unit, or the meters. We treat it as the client working with the master, LM100. We will focus on the list two models later in today's session. For the LoRaWAN, we got the Modbus RTU to the LoRaWAN converter, LR140. It can convert the Modbus RTU to the LoRaWAN protocol and link to the cloud platform. For the network architecture, there are some differentiations between the NB-IoT, LoRa, and the LoRaWAN. For the LoRaWAN and the LoRa, user can design it on the network infrastructure. If you use the LoRaWAN gateway will be necessary. For the NB-IoT, you need to apply the SIM card service from the operator or carrier. So the network infrastructure is limited by them, and you will need the SIM card feed monthly. For the NB-IoT, it can do the bidirectionally communication, control, and monitor. It's similar with the LoRa. However, for the LoRaWAN, it's suitable to monitor only. According to the requirement from the customer's application, you can choose the proper one. I will talk about more in the next page. In this page, I will talk about the major differential between the LoRa and the LoRaWAN of the WoMaster devices. For the LoRa and the LoRaWAN, they are using the same 5-layer to do the modulation. The main differentiation is that LoRa is based on the link layer protocol to development, and the LoRaWAN is completely one as the LoRa protocol. Now our LoRa is belong to the class C. Simplified speaking, LoRa is more like the private protocol, and the LoRaWAN is the open standard one. For the transmit mechanism, LoRa has ACK, so that it can support the resend and more secure. LoRaWAN is without the ACK mechanism, but it's faster. However, if under the high transmit rate and the speeded transmission, it is still risky to have data loss for the boss. So that usually we use them to do the analog monitor application more for LoRa. It's used to it is used for the cable replacement application, and it also can do the simple analog control in the non-critical application with the egg mechanism. As for the LoRaWAN, it's suitable for the is suitable for the larger the network scope and collect the data to the cloud platform with the LoRa protocol. But in this case, analog control by the LoRaWAN is not suitable. Let's move to today's leading role, LoRa LM100 and LC100 LoRa controller. They are complete solution about the LoRa controller for the AIO, PWM, and the RS485. It can support two-way Modbus communication over the LoRa. User can access the data from the LED, the dimmer, sensor, meter by the different AIO or PWM over LoRa. The destination is up to the 6 km and 215 nodes to the 1 net scope. For the LoRa, for the LM100 and the LC144 architecture, as you can see, cable replacement is suitable for this kind of the concept. Depends on the interface of the connected devices. Users can choose the three-way to connect to the LC144 by the analog input and or output. There are voltage, current, PWN, plus with the modulation. LC144 can access the data from the different sensors by the AIO, like pH value, temperature, PM 2.5, or else. We also have the outdoor environment sensor ES series for your selection. With the Modbus RTU, LC144 will transmit the data to the LM100 by LoRa. The distance can up to the 6 km and the network scope is around the 215 nodes. Of course, considering the better performance in the real application, usually users don't use such many nodes in one subnet. At the end, LM100 will send the data back to the connected devices by the RS485 with the Modbus RTU. The connected devices are like HMI, PLC, PC, these devices. In this topology, we can use the LoRa to replace the cable for the wiring easier and extending the destination. Because RS485 has the length limitation and the lower the speed by the length. LoRa installation can solve these issues in the cable management. Moreover, in this LoRa network, each device has its own the Modbus ID from the 1 to the 250 and cannot be duplicated. In this way, users don't need to modify the software of the application layer for the cable replacement. Take an example. In the past, just image HMI connect to the sensor directly by the wire. And the HMI is pulling the Modbus ID 10 for the data collection from the sensor. Now, in order to extend the distance, the user just added the LC and LM between them with the different Modbus ID, and they don't need to change the polling the Modbus ID in the application there. HMI is still polling the ID 10 to get the sensor data. The whole application can be upgraded in this way. By LC, LM, LoRa devices, they can do the analog input monitor and simplified analog output control. In the edge side, with the output sensor, input controller, even the Modbus RTU can be connected with the LC and node to send this data back to the LM. Not only this, but the sound measure equipment can be integrated. So the usage of the LoRa is widely. Now let's see today's focus LC, LM, the LoRa devices. In the left-hand side is the LM100, and the right-hand side is the LC series. They look similar and are sharing the same case. We can see they have the 1.6 dBm the SMA antenna for the LoRa connection, and the 3-pin power input including V+, V-, and the earth grounding. Regarding the casing, we're using the plastic ADAN bus with the IT40 protection and the support the UL94V0 and the ATUV. There are two LEDs to show the power, the status, and the LoRa transmission. In the bottom of the casing, there are the 10 pins terminal block. Each pin has its meaning as the table. Each input, no matter the currency or voltage, contains the 2 channels. Output uses the 1 pin only. Now, all of the open clad is reserved for the option. Last, channel 8 and the channel 9 is used for the RS485 connection. On the top of the casing, there is the USB interface for the configuration. Users can configure the LoRa devices by the LoRa utility WoMaster provided. In this page, we talk about some features. First, the outlooking is used with a plastic case to reduce electronic interference, and the compact size IP40 I just mentioned, and the DIN rate style is easy to install. We also provide many ways to the IOSS relate to the different applications like the analog I/O, PWN, and the most typical way RS485. Furthermore, there's the I/Os can reach the high accuracy with the 2 per million accuracy for the voltage, 3 per million accuracy for the current. We can get a more precise number. And of course, our product can fit in the industrial environment no matter from the RF, EMI, EMS surge, or wide temperature. Now, we will show you how to install and configure LC and LR to build up a solution. First of all, user can connect the sensor to the 10 pins terminal block by the analog input or output. You can connect the pH sensor, a water level sensor, or light as a photo. Then we need to link the LC and LM by the USB ports. It's a micro USB cable to our laptop, and start the WoMaster end node utility to do the configuration by the following slides. This is the main interface of the WoMaster end node utility, as you can use it for the LC, LM, LR. This is the LoRa devices configuration. We combine all of them into the one utility. First of all, you need to log in this utility after open it. Please key in the username and the password and apply it. You can check the serial number over there. After login, we can see all of the configuration tabs for the different models here. You can change the compo, and the model name will be detected automatically. No matter LC or LM, the first step we have to log in at the beginning. The different models will be displayed the different functions here. Then we can set up the serial parameters first, like baud rate, data bit, stop bit, parity. For the LM, it needs to match the serial parameters between the LM and the connected devices like HMI or PC. If LC uses the RS485 to connect and monitor the devices, its parameters also need to be matched for sure. Then fill the Modbus ID. For the LM100 and LC, user can pick up the ID from the 1 to the 250, but it can be duplicated among the others in the LoRa subnet. In this utility, each setting can be written or read into the devices separately. For the LoRa RF parameters, for some customers, they might concern the security issue, so that we can take the 128 bits AES data encryption to secure the LoRa data. As you can see on this page. For the LM, just enable AES and set the key. According to the latency of the application, user can adjust the resend timeout setting in this field. LM will resend if out of the list timeout. For the LM devices, there are only 3 items need to be taken care. Move to the LC devices. If users config in the same page to the LC devices, in the left-hand side, the most important is the source ID. User need to fill the Modbus ID of the LM in the list field as the same group. theater. These LM and LC devices will build a LoRa subnet as the group. As, as for encryption, it's the same concept as the LM setting. All of the devices in this group should be the same. Last, the response time is for the LM only. In the right-hand side, it's just for the LC. In this block, user can configure which the RTU connected to the targeted LC. RTU means the remote transmit unit. It can be the different type of sensor, meter, or measure equipment. After writing, LC can access the data from the targeted RTU. For the LoRa RF parameters, users can configure in this page, including the frequency, bandwidth, scattering factor, code rate, theta power. These parameters will affect the performance. It will be better to discuss with us or the technical support before the changing. Especially for the frequency. Most of the LoRa modules are based on around the 400 MHz or the 900 MHz. If the wrong setting, it will make the device system abnormal. This page is used for the LoRa signal monitoring. We can get the RSSI and the SNR by the read button. Usually, we refer these the numbers regarding the signal strength for the troubleshooting. In last page of the utility is about the IoT testing. In here, you can see there are the different fields for the different pin definition, as I mentioned in the previous slide. We also can use this tool to do the troubleshooting or some tests. We can set some values to verify if the targeted devices react normally. There are the two examples. The left one is the channel 5 as the 10 volt for the output, and then we read from the channel 2 around the 10 volt here. The right one is about the current. We set the 40 microampere to the channel 4 and send the value from the channel 1. By this way, we can do the simple test and the verification here. And next time, we will introduce about the LoRa LR144 Modbus RTU, the LoRaWAN converter, and WR322GR LoRaWAN gateway, including some hands-on. And the date is the March 19th in the same time slot. For the LoRaWAN in this page is the typical LoRaWAN architecture. The IoT sensor is using the AIO or RS485 to connect to the LR140. Sensor will send the data to the LR140 by the Modbus RTU. And the LR140 will use the LoRaWAN protocol to the WR322. And then the gateway can collect all of the data in the LoRaWAN network and use the MQTT to the WoMaster private cloud platform, WoMaster and the WoMaster OTA, or the Microsoft, AWS, Amazon, these the public cloud platforms. Again, monitoring the usage is the more preferred, not the control. By the way, users can use the WR222 to collect the sensor data by the serial or Ethernet, and send the data to the platform by the NB-IoT. Okay, it's today's topic. I introduced about LPWAN related applications and LC, LM devices. Furthermore, I also give the brief about how to configure and set up the devices and application. Again, next webinar is about the LoRaWAN. Please register online, and we will send you the link later. Any question? Okay, thanks for your time to join. See you next time. The question is the LoRa gateway the converting the data for the WoMaster OTA? The answer is yes. Only the LoRa gateway can send the data to the WoMaster. Okay, thank you for you all. Thanks for your time. See you next time.